Hello, my great people. Welcome to today's class. Look at this radical equation. It's a cube root radical. The question is the cube root of minus t plus the cube root of t equal to 1. What is the value of t here? All right. Now let's see how we solve this. We take our solution first thing. If you're new here, do not forget to subscribe. And when you subscribe, turn on the bell notification button so that you get notified whenever we drop an amazing video. All right. Now, what we do here at first, look at this challenge here now. I want to move this quantity to this side of the equation. Okay, so this is going to give us the square cube root rather of minus t is equal to 1 minus the cube root of RT. Good. Now, because this is a cube root radical, we want to take the cube of both sides of the equation. All right, so we have here to the power of 3, we equally do same to this other side. And so what happened, this and this will leave, right? Then let's expand this using the binomial expansion. So we are looking at the third power. And let's get the coefficient for the third power using the Pascal triangle. So to the power of 0, we're going to have the coefficient to be 1 here. And to the power of 1, we're going to have 1, 1. And that of 2, we're going to have 1, then 2, because 1 plus 1 will give us 2, then 1. And that of 3, we're going to have 1, then 1 plus 2 will give us 3, then 2 plus 1 will give us 3, then we have here 1. So we are dealing with this coefficient here now. All right, so expanding this side of this expression, we're going to have our minus t will now be equal to, the first quantity here is 1. So this is going to be raised to power 3. So we have 1 to the power of 3, then plus this second quantity, it will be raised to power 0. And so that will give us 1. And so if we go to the next stage, we're going to have the coefficient, which is 3, then times, let's put a square bracket here. Then what is our 1? Our 1 will be raised to power 2, then times, let's put our dot here, times the second quantity here is going to give us the cube root, but here we have a minus. So we have here minus the cube root of t, yeah, all raised to the power of 1. So we close this. Then we go to the next quantity, which is also having a coefficient of 3, then into a square bracket. 1 will be raised to power 1, then times bracket. Here, we still have a negative cube root of t. So we have here the negative cube root of RT. This time, it will be raised to power 2. Okay, then close our bracket. Then plus, yeah, the third one, which is, first, second, third, fourth term, 1 will be raised to power 0, which is going to give us 1, and it will leave the system. Meanwhile, this term will now increase in power to 3. And so we will have a coefficient of 1. So this is going to give us minus the cube root of t all raised to the power of R3. Easy. Yeah, when we have minus the cube root of t raised to the power of 3, then this power will affect this because this is minus 1. So minus 1 to the power of 3 will give us minus. And so cube root of t raised to the power of 3, this and this will leave. So we are left with minus t. So on this side, we're going to have here minus t will now be equal to 1. Then this minus here will come out of the system to give us minus 3 into the cube root of our t. Okay, then we come to this other side. This 1 times everything here will give us the same. But these two, we multiply this minus 1 into 2 times, that will give us positive. And this, we multiply this. And so we are now left with our plus 3, then times our 3, that is cube root of t all raised to power 2. The minus, here we have minus, like we said before, minus t here. All right. Now look at this system here. We are having minus t here, we are having minus t here. So two of them will leave the system. Okay, so we now have 0 equal to everything else. So let's write it out first. 0 will now be equal to 1, then minus 3 into the cube root of rt, okay, then plus 3 into the cube root of rt to the power of 2. Okay, so what we do here now is easy. We want to, again, move this quantity here, only this quantity with a sign to this side of the equation. So let's move this here. This is going to give us our 3, then into the cube root of rt. This is equal to, on this side, we are now left with our 1, then plus our 3, then into the cube root of rt all raised to power 2. Let's continue here. All right. Now, from what we have here now, we are having the cube root of t and we're having the cube root of t here. So we bring another alphabet to substitute for cube root of t. So from here, we want to say here, let the cube root of t be equal to, let's say, p. I like using p. All right. So wherever we see cube root of t, let's put in p there. So this is going to give us our 3p equal to 1 plus our 3p to the power of 2. So if we rearrange this is going to give us our 3p to the power of 2 minus 3p there plus r1 equal to 0. This is a quadratic equation, right? So how do we solve this for the value of p? We use the formula method, and the formula method says that our p will now be equal to minus b plus minus the square root of b squared minus 4ac all over 2a. All right. Now, we bring out our a, b, and c. From this equation, our a is equals to 3, our b is equals to minus 3, and our c is equals to 1. So let's substitute in and see what this gives us in turn. So we're going to have p will now be equal to minus our bracket minus 3 close bracket plus minus the square root of our minus 3 all raised to the power of 2 minus 4 the times, what is our a here? Our a is 3, so times 3 times 1, everything all over 2 times 3. So let's check this out here. So this is going to give us minus times minus, we have 3, the plus minus the square root of 3 to the power of minus 3 to the power of 2 will give us 9, then minus 4 times 3 will give us 12, times 1 will give us 12. Everything all over our 6. Simplifying down, this will give us 3 plus minus the square root of 9 minus 12 will give us minus 3. So we have here minus 3 all over our 6. All right, so let's continue here. So what is our p now? We can split this, but before then, we can rewrite this minus 3. Remember that the square root of minus 1 is equal to what? Iota. So we can rewrite this and bring iota into the system. So this will give us our p is equal to our 3, then plus minus iota root 3 all over 6. Simplifying down, this will give us 3 all over 6 plus minus our iota root 3 all over 6. 3 here 1, 3 here 2. So we now have our P1. So P1 is equals to 1 all over 2 plus our iota all over 6 root 3. And we have our P2 is equal to 1 all over 2, then minus iota all over 6 here, right? The root 3. Now, these are the two values of our P. But we recall a place where we said, let P be something. Yeah, we said let cube root of t be equal to p. So we're solving for the actual value of t. So how do we get the value of t? So we're going to substitute each of these values into this expression here. So let's continue here and see what this gives us a turn. All right, before we continue, if you've not subscribed, subscribe to this channel. Okay, now let's continue. Now from here, we said something that the cube root of rt should be equal to our p. So let's take this as p1, and we're taking this first one here now. So if we replace that, this is going to give us our cube root of t is equal to our 1 all over 2, the plus iota all over 6 root 3. Okay, we have to take the cube of both sides of the equation. So raise this to power 3, and we equally raise everything here to power 3. And so this and this will leave. So we now have our t will now be equal to, now if you use binomial expansion again to open up this, or which I have done that already, then this will give you 0.1924 dash to 988 iota. So this is our T1. Okay, so how do we get our T2? We're going to get our T2 from P2. Okay, so we have our T2 will now be equal to, if we substitute that into this system again, then we're going to have the same answer, but this time it's going to be negative 0.1924 dash then 988 iota. All right, so these are the two values of t that will satisfy the original radical equation. Okay, so if you learned something from this video, drop it in the comment section. If you've not yet subscribed to our channel, do so, because here we drop videos all the time. Thank you for watching. Thank you for being there. See you in our next video clip. Bye for now.